Hi, Joe Cerrone here with MFG 141 with Francis Barrar in our weekly Zoom classroom meeting for Saturday. The date's wrong. It's actually the 18th. I forgot to update that, but I think it's a small detail. Here's our agenda for today. We're continuing through the CNC programming lessons in CAM Instructor. And so we're into the point where we're writing programs now using Notepad, and then we're using a simulator to see how those programs work. This discriminator software is available for download. Students can download it by clicking on this link and be able to verify their programs. Or if you want, you can VPN and use the CNC Easy Pro. And to VPN in, the instructions are in the main splash page. All right. So all of these programs work basically the same. We print out the instruction sheet, and then there's videos to support the lessons for those. And the videos are relatively short. You can see how they're set up right here in the task list for this. When you complete it, you'll get a green check mark, and then we can see if you've been going through and doing the work. Over in the content section, we've been putting the labs in. So lab 1 was this coordinate table with the CNC programming workbook. I've graded those assignments. You should have submitted lab 1 to the lab 1 lesson folder, and I gave half a point for each correct answer. Lab 2. Lab 2 is G-code programming codes. And we talked about this. These G-codes are used to write the programs essentially. And you kind of want to start to memorize these codes so that if somebody asked you, what does G1 do? You would know the format for that. G1 is a linear interpolation move. It moves at a linear speed in inches per minute. And we will show you how to write those programs and set those things up. G2 and G3 are circular interpolation, meaning it's for arcs. G4 is a dwell command, setting the XY plane, inches, metric. Homing the machine, we use this code a lot. And G40, cutter compensation cancel. We use that quite a bit as well. And so the lessons are given, and here is the instructions for that. So if we look at the instructions for lesson 2, there really isn't too much. So if we download that and we open it, the programs are set to be run on the machines. And these are the tools that would be in the carousel for the program that we will write. So we're looking at an end mill, flat end mill, 1/8 of an inch, 1/4 of an inch, 3/8 of an inch. So we have a number of end mills. We have a spot drill, a drill, a number 7 drill, a tap, and a center drill. This goes through our G codes in sequential order and how they work. It's not essentially how they work, it's just telling you a little bit about them. As we go farther into it, we'll be able to go through and designate all of the options within those codes. And then M codes are used as miscellaneous codes for things like optional stop, turning on the spindle clockwise or counterclockwise, ending the program and stopping the spindle, creating tool changes, turning on and off the coolant, and ending the program. So in lesson 2, we then walk through how to write a program. And so in lesson 2, we start off with the program number, and then these N values are sequence number. So N10 and 20 and 30 are not required, but they give the operator the ability to diagnose and troubleshoot the program. as we go through, we're going to work these standard programming languages. And so line number 10 just says to work in inches. It's important that you start with the percentage sign because that is a start flag and allows us to download that to the control. Here's our program number. This is going to be an inch program. And then you want to be able to read these and to be able to understand what those codes are doing. Here's our tool change. And then here's our basic first move for the tool, going at a rapid rate using absolute programming to our G54 coordinate, which we picked up with our edge finder, setting our spindle speed and turning the spindle on clockwise. And then we also designate the tool length in the next line, G54H8. So the height number will match the tool number, T8H8. And here's an example of a program for an end block, or what we would often do before we make a tool change. Here's our tool change lines. And here's our first program. If we look at this first program, it's a very simple part, 3 inches by 3 inches by 1/4 of an inch thick, 3 holes. And all we have to do for this exercise is to fill in these 3 coordinates on each side. And then write the program. So lesson 2, what you should be submitting should be a program that's written with Notepad. Here's an example. We started off with a percent sign. And then this is our program number 02. I typically add more numbers to this, so I would typically make this 2001. And then I typically like to put my name on it. And then here's line number 10, G20, line number 20, G0, G17, G40, G49, G80, and G90. And so this goes and sets up that we're in rapid mode, sets our XY plane, cancels cutter compensation. G49, not sure what that does off the top of my head. G80 cancels canned cycles, and G90 works in absolute programming. Then we go to tool number 6 and load the spot drill. We designate the first position as G90, G54, X1, Y1, spindle speed M3. And so the tool will wrap it to the location on the part that's going to be from our 0 location, 1 inch over and 1 inch up. Picks up our height offset and then brings the tool down 100 thousandths over the part. And then with G1, we drill into the part. We can take a look at those in a simulator if I go with the CNC EZ simulator. And I should be able to open this notepad file within it. And so if you're working with CNC EZ, you can VPN into the campus. If I say file new, I'm going to say that I want to go with a mill file, and I'll say OK. I think it's mill file. Let me take a look. It might be text file. Let's try text file. Yeah, it would be text file. And so here's my program file, and what I can do here is I can go over to my notepad and I can just copy it from here to the end. Control C, come over here, Control V, and here's my program now that I have written. Once I have the program written, I can then go through and simulate it by going under New Project. Let's see. Yeah, New Project. And we'll call it L2. We'll set up the machine that we're going to be using for this. We'll be using a Haas mill. We'll take the defaults for inches. We'll use the inch library and the inch units. And then we'll set up the dimensions of our workpiece. And the width is 3 inches. The depth is 3 inches and the height is 0.25. We'll use whatever material is the default. We're not going to worry too much about that. This is where we could have added those files. We'll say next, and we'll say okay, and we'll say finish. Open the project now, and I'll hit X here. So I'll have to reload the program itself by going to the new text file, saying okay, and then pasting those back in. Once we have the program written and we want to simulate it, we can go under the options and we can set this up with our tooling library. And so we can say edit tool turret, and we can say tool number 1, and we'll look that up. Tool number 1 is going to be a spot drill. So I'll just pull this one as my spot drill, and I'll add it for tool number 1. Actually, that should have been tool number 6. And then the next tool that I have in here will be tool number 7, which will be a 1/4 inch drill. So I'll get the 1/4 inch drill. I'll set that as 7. I'll add that tool and I'll save it. Take the defaults, yes, and okay it. And we should be able to simulate it. I'm going to turn off some of these windows, work windows. We'll get rid of the depth bar window. That's good. We have enough here. And then as we go through and we simulate the program, we can go into options, single block, automatic mode, and we can then walk through the program. I'm not sure if my view options should be on follow tool. Let's get rid of that. Let's take it out of single block. And let's just see what we get. So right now it's got an error as far as where the positioning is on it. We can certainly figure out how to fix that at another moment. But it looks to me like under my options for my workpiece, and I'm just going to pause the video here while I fix that. So to get this to work properly, we have to have the G54 set up at 1.5 in X and 1.5 in Y. And then we can apply that and okay it, and now it should work just fine, hopefully. Let's see what happens first before I reset it. So if I come back here and go to automatic mode, right, that was it. All right, so you can simulate your programs using CNC Easy if you VPN in. See if I can get back to an isometric view. There we go. It's got the origin right there at the center, but again, thanks. So as we go through and write these programs, you can simulate them using CNC Easy. You'll need to VPN in or come into the lab, it's no problem. If we go under options and work with single block, we can just walk right through it. Okay, percent sign, starting flag, program number, G20 is inches, G00 is 17, 40, 49. This is basically a standard setup that tells us we're in rapid mode, we're using the XY plane, we're canceling cutter compensation, we're canceling tool length, we're canceling hand cycles, and we're using absolute programming mode. And what we're going to do is we're going to spot the hole, so we go through and we do a tool change, T6M6, M6, which is tool number 6, which is our spot drill. Then we wrap it to a position from the 0 point, -1, -0.875. And then as we go through, it will then go into the Z depth of -0.15, 150 thousandths at a feed rate of 11 inches per minute. And then it will go to the next position, do the same, And then here we go with G53, G0, Z0, M5, stops the spindle. Bring it to our next location, tool change, tool number 7. And then we go through and we drill these holes. And so when we set up tool number 7, again, the same standard start line, G0, G90, G54, tells you which origin we're using, and then the X and Y values, spindle speed, is in one clockwise. Set up our height offset, tool will hover 1,000ths over the part, and then it will drill into the part, -0.35, retract, go to the next position, drill, retract, next position, drill, retract, home the machine, safety line, and that completes the program. So that's what we can simulate. We can also use the backlog software from the discriminator, and what you'll do then is you'll turn those files into the assignment folder. We're assigning them to right here. They'll be due next Thursday, 11:59 p.m. If you want to take a look at assignment number 3, more of the same. This time we'll use canned drilling cycle to be able to do this more efficiently, which is a G80 command. So again, we just are writing these programs, and then as we start to understand better how this works, we'll be able to then write the program codes. Our plan is to demonstrate the use of these program codes on the CNC machine in the lab. So if you're planning to get the NIM certificate, there is a hands-on component, and will allow you in the lab to go through and to do the machine startup, be able to change the tools, and set the offsets. And then finally, lab number 4. Lab number 4 is again writing program BCN cycles. All right, that's basically our work for this week. Be sure you have lab number 2 in the assignments folder by Thursday, 23rd at 11:59. With that, I'm going to end this recording and open things up for questions.